Human speech chain generating mechanism: lungs, trachea, larynx, vocal folds, pharynx, and then one goes to the nasal cavity and the nostrils, the other line goes to oral cavities, teeth and lips. Vocal cords slightly open, voicing, vocal cords fully open, voiceless. Auditory feedback, listening to the vocal tract, the vibrations formed in muscles of throat, cheeks, tongue and lips, as well as the vocal cords. Auditory feedback, the person speaking is hearing himself via sound waves picked up by his own pinna and also a process of bone conduction. Speech also monitored via tactile feedback with lips, tongue and teeth, and kinesthetic feedback, information regarding movement, position and placement of the organs and muscles used in the speech process. This is non-auditory feedback. Long-term average speech spectrum, banana shape on an audiogram. Clarity versus intensity. Voiced sounds, all vowels are voiced and only some consonants. Voiceless, only consonants. Consonants can be voiced or voiceless. Consonant produced depends on the type of closure and includes plosives, fricatives and nasals. Example of plosives: t, d, k, j, b, p. Example of fricatives: f, v, th. Example of nasals: m, n, n, g. Three of the most intense words are thin, for and packed. Three of the quietest words are ton, top and talk. The spectrograph measures frequency, time and intensity and can be used to display on a spectrograph certain aspects of the speech signal, and these peaks are known as formants. Any acoustic feature employed by listeners in making phoneme discrimination is referred to as an acoustic cue. For example, plosive consonants are distinguished from other consonants by a brief interval of silence during which the airflow is completely stopped for about 50 to 100 milliseconds, followed by a sudden onset of energy from the explosive release of air. Conductive loss, typical flat audiogram, where there is more severe loss in low frequencies, tends to affect the volume perceived more than the clarity. Sensory neural loss, the typical high frequency loss, affects the perception of high frequency cues, and in particular this creates problems with consonant perception. Hearing aid is not a new ear, but merely an artificial means to enable the user to make the best possible use of his residual hearing, ideally improving speech discrimination abilities to an acceptable level. Discussing cleaning and simple maintenance of a hearing aid. Show client how to clean the aid casing on a daily basis. Damp cloth, not a wet cloth. No reagents. Advise on the removal of wax from the sound outlet and vent. If applicable, advise on the daily use of wax cleaner, showing the client how to apply the fluid without allowing it to drip into the sound outlet. If a post-oral system has been fitted, show the client how to remove and clean the ear mold by washing it in warm soapy water. Pay particular attention to how to dry the ear mold and tubing, as even a small drop of water can interrupt sound flow between the aid and ear mold sound outlet. Advise on general care. Turn aid off when not in use or remove batteries if aid is not to be used for a prolonged period. Always keep the aid in its protective case. Do not drop the aid. Advise against extreme temperatures and extreme humidity. Caution regarding hair lacquer. 3 stages of re-education: hearing, listening and understanding. Auditory training pyramid: initial period of hearing experience, recognition of sound source, gross discrimination, discrimination of intonations, discrimination of vowels, discrimination of consonants and speech discrimination. Manualism is the term used for any communication method using hands or fingers to convey information, i.e. sign language, finger spelling, cued speech. Oralism refers to lip reading. Speech loss will deny the sufferer full auditory feedback, and this could result in shouting, whispering or distorted speech patterns. Specialist teach therapist methods include A. Speech training aids, powerful wideband amplifiers. B. Laryngograph, like a displayed analogue of speech patterns to enable the impaired speaker to modulate his voice to match the pattern. Visual clues, face, lips, teeth, etc. Tactile clues, sense of touch and position of the different speech organs. Kinesthetic clues, interpreting the sense of movement of the different speech organs. Hearing aid system is a device which should enable a hearing aid impaired person make the maximum use of his residual hearing, should provide optimum speech intelligibility and the maximum amount of useful information from all other sounds with a minimum of distortion and interference from unwanted background noise. Remember, for post-oral aids, wide choice of electrical fittings, rapid assessment of comparisons of two different types of aid, disadvantages resonance from tubing and moulded in, etc. Difficulty in using the telephone with no telecoil. All in the ear advantages, retains piano function, one-piece construction. Disadvantages, contraindications, risk of feedback, occlusion effects, especially where low-frequency hearing is good. Deep, semi-deep canal aids advantages, delivery of output into the bony portion removes acoustic occlusion effect, less gain required because of the proximity. Microphone protected from wind noise, easier use of telephone. Disadvantages, contraindication, small, no user control adjustments, too small. May require venting because of occlusion. If there's a binaural fitting question, start with the physiology, and then the advantages of the actual aid could be improved localization, improved speech discrimination, less gain per aid required, summating, improved perception of faint sounds, makes best use of residual hearing in bilateral loss, balanced hearing feels more natural, rehabilitation periods are often shorter. A-class amplifier advantages, suitable for low to medium gain applications, predictable battery life, inexpensive and simple to build. Disadvantages, limited to low to medium gain, the same bias current is drawn even when no signal is present or when gain is set to zero. The higher the designed in gain, the greater the bias current and hence the shorter the battery life. B-class amplifier, push-pull amplifier, 2 output transistor stage. Phase splitter splits the phase of the signal, positive, negative. Current drain is very low in B-class when there is no signal present. Current drain is dependent upon the amount of gain required. Battery life is related to volume control settings and input signal intensities. B-class advantages, higher gain available than A, improved battery life compared with equivalent power class A, less distortion and noise. Disadvantages, less predictable battery life, physically larger and more expensive than class A. K-class amplifier with a D-class receiver, think of K for cochlea, amplifies faint sounds, attenuates loud sounds. Operates by continuously variable degrees of compression, which is controlled by the input signal intensity. K-class amplifier advantages, amplifies quiet sounds, attenuates loud background noises. Extended frequency range gives high fidelity reproduction. Designed to drive a Class D amplifier receiver, allowing full use of extended frequency range. K-class amplifier disadvantages, circuit noise. Initial complaints of insufficient gain from users accustomed to excess bass sounds. Purchase cost. Telecoil advantages, removal of unwanted acoustic interference, background noise. No loss of signal strength as long as the user is within range of loop. User has independent control of intensity. Disadvantages, electrical interference, fluorescent lights, weak or dead spots within the area of the loop. Loop overspill from another room. Biggest disadvantage is the microphone is disabled. Mercury battery cells 675 180 mA, R13 90 mA, through 312 45 mA. Zinc air cells 675 360 mA, R13 180 mA, 312 90 mA, A10 45 mA. Mercury is in cells widespread use, rapid decay when voltage drops, leak resistant, but they are toxic. Zinc air, approximately double life in continuous use compared with mercury cell. Rapid decay when voltage drops, needs good supply of oxygen to give steady current. Has been a problem in some high gain push-pull aids, leak resistant, less toxic than mercury. Ohm's law, voltage equals current times impedance. Battery life equals capacity divided by current drain. Signal to noise ratio, binaural discrimination, wanted versus unwanted noise. Sensorineually impaired hearing aid users will need at least plus 20 dB SN ratio to discriminate wanted from unwanted sounds. Systems to try and aid this problem are direct audio input induction loop systems, ASP and K-amp. This distortion is due to the non-linearity of hearing aid component performance and results in frequencies not present in the input signal being present in the output signal. Harmonic distortion, whole number multiples of input signal frequency. Intermodulation distortion are sum and differences of two or more input frequencies. Frequency distortion falls outside the effective frequency range of the hearing aid. Acoustic feedback, the output from the receiver is reintroduced, the signal is reintroduced to the microphone, sets up a cyclical whistle. Mechanical feedback, vibrations from the receiver are transmitted through the body of the hearing aid. Frequency response of a hearing aid is the relationship between output and frequency at a particular input sound pressure level and under specified operating conditions. Peak clipping affects the output signal of the hearing aid so that the natural saturation point is reduced. This is controlled by output intensity. Peak clipping distorts the waveform and interferes predominantly with the vowel sounds. Automatic gain control affects the gain of the hearing aid by reducing the rate of increasing gain as the signal intensity presented to the amplifier intensifies. It's controlled either by output signal intensity or input signal intensity. Does not distort the waveform, but there is a small time delay in the switching in and out, known as attack and release time. Comparison between AGC output and input. AGC output, output controlled, output fixed, irrespective of volume control. User's ULL cannot be exceeded. Relatively longer attack time. AGC input, input controlled, maximum output dependent on volume control. User's ULL may be exceeded. Relatively short attack time. Adaptive signal processing. New generation of hearing aids whose frequency response and amplification characteristics automatically change according to changes in the characteristics of the input signal. ASP has a circuit design that modifies the signal by deciding when to amplify and when to suppress sound. ASP is non-linear, mimics the non-linearity of the healthy human ear, i.e. concha resonance, meatal resonance, conical shape of tympanic membrane, selective tuning of articular chain, etc. Cochlear microphonic summative potential. Again, a sensorineural impaired person needs plus 20 dB on sound to noise ratio to gain intelligence from speech. Two-channel ASP-A works by dividing the frequencies into low and high frequency channel. The input signal is split between these two channels according to the frequency. This can be adjusted. Threshold limits are adjusted so that only those low frequency signals which are intense enough to interfere with the higher frequency speech sounds will be compressed. Digital signal processing. Manipulation of an analog waveform may produce undesirable level of distortion, which may impede clarity when the electrical wave is transduced back to an acoustic wave. Digital circuitry introduced, which is transduced into a series of electrical pulses rather than a recognizable waveform. Combines high-frequency triangular carrier wave of 110,000 Hz with much lower frequency signal wave 200 Hz to 6,000 from the microphone to produce a frequency modulated wave. This is then passed to a comparator which produces a pulsed square wave. Digital codings are derived from this. Advantages of digital processing: flatter and wider frequency response, large distortion-free dynamic range, improved signal-to-noise ratio, less internal noise, less harmonic distortion, improved ability to manipulate signal wave, greater accuracy, less distortion. Disadvantages: complex algorithms, increased power requirement, high current drain. Digital circuitry takes up more space, higher purchase cost. Ancillary aids to hearing: induction loop advantage, removes signal, loss of signal intensity normally occurring as a distance between speakers, removes interference from background noise, acoustic feedback is eliminated, user can vary loudness for himself. Disadvantages: fluorescent light fittings, loop overspill, microphone is switched off when in T position. Radio aids are primarily used in educational establishments, mostly by the profoundly deaf. Advantages of radio aid system: excellent signal to noise ratio, only wanted sound is received, no loss of signal intensity irrespective of distance, mobility of listener from classroom to playground, no overspill effects like loop system. Disadvantages: overuse can create overdependence. High initial purchase costs. Ancillary aids to hearing telephone. A. Amplifying handset with own volume control. B. Magnetic flux field booster for telecall use. C. Telephone linked to personal computer, provides visual display. Ancillary aids to hearing television. Personal TV amplifier. Sends the audio signal via wire to the user's personal earphones. Cordless TV personal amplifier. Uses infrared transmission. Domestic induction loop for TV set, direct audio input. CFAX teletext. Miscellaneous ancillary aids. Warning light systems, usually flashing. Door, telephone, fire alarm, smoke alarm, alarm clock. Vibrating pad system for door, telephone, fire alarm, smoke alarm. Extension telephone bells and doorbells, buzzers instead of bells. Radio aids. Vibrate converts acoustic stimuli to tactile stimuli. Hearing dogs. The role of the hearing aid dispenser is to assess each client with regard not only to their audiometric ability, but to a more holistic view of the person beyond your audiogram. HAC Code of Practice dictates to us in clauses 2, 3 and 4